3D printing isn't only used to make small parts. It can also be used to build large structures quickly and cheaply. In Austin, Texas, for example, people have used 3D printing, also known as additive manufacturing, to make concrete shelters for people experiencing homelessness. But concrete has some environmental downsides. Some studies estimate that making concrete generates as much as 8% of human-produced global CO2 emissions, and the material is difficult to recycle when it's no longer needed. So at Texas A&M University, researchers are developing alternative materials to reduce the industry's reliance on concrete. They propose adapting locally harvested soils for 3D printing. To demonstrate the idea, they created this material, which is made with clay from a colleague's backyard.
It's from a professor's backyard. So our approach was to take the most complex form which is available in nature, because if we prove that we can do the complex mixture, then doing non-complex mixtures and store-bought mixtures are much easier.
To make a 3D printable material from clay, Ayushi mixed backyard samples with sodium silicate and an alkaline catalyst. The silicate precursors react to form a cross-linked siloxane framework that binds the clay particles together as the printed material cures. Ayushi tailored the formula so it would flow easily through a 3D printer and cure quickly to support the next layer of material. Then she used it to build a test structure. Group leader Sarbajit Banerjee says the chemistry makes it possible to use a variety of local soils and avoids the need to transport materials long distances.
If you could do a quick analysis of the local soils, we'd like to have a fairly versatile chemistry toolkit that you could just adjust a little bit and then sort of get to printing.
For now, Sarbajit says the material is best suited for non-structural elements like a building's facade, but the team is working to optimize their chemistry toolkit to produce stronger materials that can flow through giant 3D printers while keeping the technology's carbon footprint in check.
If additive manufacturing takes off and it happens only with concrete, it would increase the carbon footprint of the construction industry. I think we're poised on the brink of a huge paradigm change in construction, and chemistry is going to be a big part of that.